Hello, everyone, and welcome to the sixth and the final webinar in our cybersecurity awareness webinar series. I'm thrilled to have you join us as we wrap up this incredible journey of learning, collaboration, and insight into the world of cybersecurity. This month, we have had the privilege of hearing from leading experts on the topic that have spanned into cybersecurity research, into cybersecurity outreach, innovative datasets of IoT environments, cloud resilience, and the cybersecurity landscape throughout, throughout Canada. Each session has provided us a valuable perspective and the practical tools of tackling the unique challenges in our rapidly evolving digital landscape. So for that, I thank you, our speakers as well, who joined us in the webinar series thus far. Today, we're excited to continue this journey or webinar series by inviting our guest, Amir Firouzi, who will guide us through the powerful application of Elasticsearch in data analytics and machine learning. This session promises to be an engaging exploration of how Elasticsearch can transform data into actionable insight, pushing the boundaries of what's possible in data-driven decision making. So at this point, I will open the floor to our guest today, Amir Firouzi. Amir, before we step into the webinar, why don't you tell us something about yourself, and then we can, go into the presentation.
Thank you, Sumit. Hi, everyone. I'm Amir. I'm a PhD student here at University of New Brunswick, and I'm also a cybersecurity researcher at Canadian Institute for Cybersecurity, CIC. I'm happy to be here with you. My areas of interest for research would be IoT security mostly, and most specifically industrial IoT. I'm also interested in the areas like data pipelines, data engineering, data analytics, machine learning, NLP, and I hope with this presentation today, you get interested in diving into some technologies working with data like Elasticsearch or Elasticstack.
Thank you. Thank you, Amir, for this really brief and insightful introduction. And with this, again, I will say the floor is open to you. Looking forward to your, presentation.
Thank you. Thank you. Let me first share my screen. So today we're going to talk about Elasticstack, which in my opinion is one of the most powerful tools when it comes to working with data, storing the data, retrieving the data. And nowadays, it's not limited only to storing and retrieving the data, but also processing the data and getting insights and all sorts of information from your data. So for today, today's webinar is divided into two parts. In the first part, within these slides, I'm going to very briefly introduce Elasticsearch, Elasticstack, and go over a little bit of theoretical stuff like the modules, the applications that it's used for. And then in the second part of the webinar, I'm going to give you a hands-on experience with Elasticsearch, Elasticstack, and a total process of how we get the data, import the data into Elastic, then retrieve the data, run queries over the data, and then the most interesting part would be running machine learning algorithms on our data. So this is going to be the outline of my presentation. First, I'm going to introduce Elasticstack, go over a little bit of history, then review some of the main modules of the Elasticstack, the main applications that it can be used, and then we will switch to the fun part, the hands-on experience. So when we talk about Elasticstack, we mainly mean three modules, which are Elasticsearch, Logstash, and Kibana. These are the three main modules that make the Elastic Stack bundle. Obviously, the main module would be Elasticsearch, which is the distributed search and analytics engine. This is the module that allows us to basically first store the data and then gives us some ways of interacting with the data, such as retrieving the data, running complex queries over the data, and in other words, provide us with some analytics tools. And Logstash is the second main module of the Elastic Stack, which is responsible for collecting the data and also processing the data. And we will see this module in action as well during the hands-on experience. And the third main module of the stack would be the Kibana, which is the visualization layer. This is actually the UI that allows us to interact with all of the different modules in the stack, such as Logstash, Elasticsearch, and different parts. So this is the visualization tool that gives us so many options, and we will go through this module as well. So what are the main characteristics of Elastic Stack? First of all, as you might know, it's scalable and it's real time. So it allows us to scale up based on the size of our operation, the size of our data, the nature of our data. And the bigger the data is, the more power we need to store the data and also to retrieve the data. So it's super very, very, very scalable. And it's also capable of getting the data in real time and processing the data in real time. And also, the second characteristic would be the various number of applications that it can be used for. So it's just basically gives you a very powerful tool for storing, retrieving, querying the data, and also processing the data. And you can use it for whatever application that you have, including log analysis, security monitoring, operational intelligence, and so many other applications that it can be used for. And the third main characteristic would be the flexible integration. So it supports many, many data sources, but you're not limited to those data sources. Whatever extended external sources that you might have, you are able to somehow connect these external sources to your stack, and you are able to receive the data, store the data, and then start processing the data. A little bit of history. So the Elasticsearch initially was developed and introduced in 2010. It was originally developed from Apache Lucene, which was a search engine. And it got really popular really fast because of its real-time capability, real-time search capability, and its scalability. In 2011, Logstash was introduced for the first time, and it was introduced as an open source tool, which was able to collect the data, parse the data, and process logs. And it allowed users to create end-to-end data pipelines. And by pipelines, we mean the capability of receiving the data, pre-processing the data, and sending the data to Elasticsearch for storage. In 2013, the Kibana was introduced, the third module of the stack, which was mainly the visualization layer. It allowed us to create dashboards, charts, graphs, maps, every type of visualization that we need to get some insights from our data. And in 2015, it was the first time that the creators officially bundled these three main modules together and called it Elastic Stack. And in 2016, another very cool feature of Elasticsearch was introduced, which is called Beats. It has so many submodules, which we will get into later. But basically, Beats is uh, a lightweight data shipper that allows us to send data from external sources to Logstash or Elasticsearch. So this is the part that make Elastic Stack more flexible, and it allows us to connect our stack to many external sources. And in 2017, one of the very advanced modules of Elastic Stack was introduced, which is machine learning. And we will get into this in more detail, but to just very briefly introduce this, this is basically an embedded machine learning capability inside Elastic Stack. It allows us to run machine learning jobs such as anomaly detection, predictive analytics, directly within the stack itself without requiring any external source or program. And until present, until this day, they are continuing to add more features to Elastic Stack, and I'm not really surprised to see more advanced stuff being introduced shortly, such as support of deep learning models and other types of advanced analytics tools. To go over some core and main modules of Elastic Stack, we already introduced Elasticsearch, Logstash, and Kibana. Another cool feature of or module of Elastic Stack would be Beats, which has so many other submodules such as file beat, metric beat, packet beat, audit beat, heartbeat, and winlog beat. All of these modules allow us to connect our stack, connect our Elasticsearch to external sources. So for example, FileBeat is useful when we have multiple files, and these files are automatically generated. New data are being written to these files, and we want to parse these files and send the contents to Elasticsearch. Metric beat is useful for continuously monitoring states of services, servers that are running, and we want to just keep looking at the different states of these services. Packet beat, again, is used for constant monitoring, and other submodules are very useful in different use cases. Like, for example, winlog beat is used for parsing and sending Windows logs to Elasticsearch. Another cool feature of Elasticsearch would be Elastic APM, which stands for Application Performance Monitoring. It's responsible for tracking and monitoring application performance in a real-time way. And it also gives us some information about different bottlenecks or errors that we might have in our applications. And another advanced module would be Elastic SIEM, which is a tool for security monitoring and threat detection. Another module would be Elastic Machine Learning, which we will cover very briefly in this webinar. It allows us to run various number of machine learning jobs within Elastic Stack. And another very advanced feature or module would be Elastic Workplace Search, which is a tool that gives us the ability to search within the internal company data. So we might have, in our company, we might have data coming from multiple data sources. And with Elastic Workplace Search, it gives us the ability to search within this universe data that is collected from different multiple sources. And last but not least is Elastic Enterprise Search, which is kind of a solution for applications and websites that need fast and reliable search for their users. So this module allows you to provide search capability within your application to your end users. And to talk a little about different types of applications that we can use Elasticsearch for, we can obviously the best one and the initial use case was log analysis. Log analysis was the main reason that Elasticsearch or Stack was created in the first place. And the second one is obviously event data analysis. It's best for scenarios that you have event data. Event data obviously is a stream data that is generated every second, and we want to run different types of analysis on this data. The third application would be the security monitoring, and this is gaining more and more attention these days. Elasticsearch is being used for security reasons every day, and this is something that I'm actually using it for security analysis, for monitoring purposes over network data or other types of data that is being generated by devices in a network or in an environment. The other application would be operational monitoring. You might have an environment that so many things are happening, right? For example, you have transactions, you have users' data, you have so many operations going on in your environment, and you want to monitor these type of operational data to see what's going wrong, what are the errors, and what are the bottlenecks, and how is the performance, and some kind of this kind of monitoring. Business intelligence is another application. Anomaly detection, as I mentioned earlier, which is a kind of subcategory of security monitoring, is another application that we can use Elasticstack for. Infrastructure monitoring, you might have a very big environment composed of many, many different sensors, different devices, network devices, and you want to just monitor your infrastructure to see what devices are online, what's the status of each device, how is the performance of each device, how much capacity or RAM or CPU each server, for example, has left. This kind of infrastructure monitoring is another case that you can rely on Elasticstack. And obviously, data search and exploration is another application that we can use Elasticstack for. And some real-life use cases, many companies are using Elasticstack nowadays. These are only a few examples of the companies that have declared their use of Elasticsearch, like Uber, for example, use it for monitoring and analyzing real-time data. Netflix is using Elasticstack. Slack is using Elasticstack. Airbnb is using Elastic for log management and security monitoring. LinkedIn is using Elastic for its search capabilities. Cisco is using Elastic for its network performance monitoring, and many more companies that use Elasticstack products and modules every day in their business. Okay, so I'm gonna switch to the second part of my presentation, which is the hands-on experience. And in this part, we will first go over a few basic steps of how to import the data into Elastic. There are a lot of ways to do that. We will cover two types of data import into Elastic. Then we will quickly review the main data visualization capabilities of Elastic. And obviously, we will use Kibana for that. And then we will review some of the data queries that we can run to retrieve our data, to get statistical information from the stored data in Elastic. And last but not least, we will quickly cover the machine learning module, which allows us to train a model and then use this model inside Elastic Stack. Okay, so let me very quickly switch to Kibana. Okay, so this is the Kibana, which is the visualization layer for working with different Elastic Stack modules. And the first thing, I'm obviously, I need to mention this. I'm using the cloud version of Elastic. And this is something that I really suggest if you haven't worked with Elasticsearch, this is the perfect way to get started with Elastic, because in a matter of couple minutes, you can set up your own deployment environment, and then everything is accessible to you, Elasticsearch, Kibana, Logstash, everything. And then you can start experiencing with Elasticsearch without requiring the installation and setting up Elasticsearch on your device or in your environment. And obviously, you can use the first 2 weeks trial that ElasticCloud gives you, and this is a perfect way to start with Elasticsearch. So the first step would be to get some data, right? Because this is what Elasticsearch is for. To store the data, then we want to just manipulate the data, work with the data to get something out of it. So the first step would be to import the data. The best way to start with importing the data is to first try some sample data that Kibana allows us to use. And there are a couple of data samples or data sets that are available through Kibana. And I'm going to use this sample flight data. And as soon as I hit add data, this data set is going to be imported into Elasticsearch. This is not a very gigantic data set, but it's perfect for introducing some of the basic features of Elasticsearch and Kibana. So after importing the data, we can switch to different parts of the data visualization layer. Like, for example, in this discover, you can very quickly go over the imported data. You can see the different features that it has, the values for each feature. You can go over the JSON format for each index. And also you can filter the data based on the date to just see the data for certain date ranges, or you can sort the data based on different fields. So this is a very basic way of getting to know your data, to discover your data. The second part of data visualization that we are going to cover is the dashboard, which is a very, very powerful tool to visualize our data. So with this feature, you can create basically every type of dashboard that you might need for your data. You can add different type of elements like numerical statistics, percentages, date ranges, different types of charts, the data tables that shows different characteristics of your data. Everything that you might need to monitor your data is available through these dashboards. And these are easily customizable. So you can add any type of pie charts, line charts, bar charts, everything, anything that you need to visualize your data. And this makes more sense when you have a stream of data coming in. So for this data set that we are using, everything is static, right? Because we just imported a data set and it's not changing. But if you have data that is getting collected every second, and these dashboards are super handy, super useful, because you can just monitor your behavior of the data, incoming data, and you can monitor everything. Like, for example, this data is for flights, right? You can quickly observe the percentage of canceled or delayed flights. And so let's assume this is your business. Once you have some increase in the number of canceled flights, you can set alerts that, for example, someone needs to do something, or you need to go further into the reasons for these canceled flights, or whatever event that you might concern you. So these dashboards are super useful to monitor your business, your data. The other part that I'm going to quickly show you is the map. Let's just quickly open these tabs. So within this map feature, you can just, if your data is geographically distributed, if you have some location properties, location fields in your data, you can just filter the data and show it over a geographical map. For example, how many flights do we have in this particular location? Or you can add other features as well. And within these canvases, again, you can create some very useful dashboard types of information. Unlike the actual dashboard, in here, we don't see very complicated charts and tables and maps. In here, we just see a summary of our data. And again, if this is a stream data, it makes more sense because these are changing constantly. And within this graph, you can visualize your data based on different features that you have. And so, for example, in here, we have added a couple of fields like the carrier, the destination of weather, and it just illustrates the data based on these fields that we have added. And we can add other fields as well, like, for example, the origin or other fields, for example, the origin country. And it again tries to add these fields to, if it finds any relations between these fields, it tries to add these fields data to the chart. So we are selecting some fields that doesn't have any relation. Yeah, so for example, these new fields are shown in the graph to see any relation between different fields of your data. It can be very useful when you want to cluster your data. So for example, if you have network data being stored in one index, and then you want to find relations and find clusters based on different characteristics of your data, this graph can be super useful. So these are the basic tools that can be used for data visualization. Let me see my notes to see if I'm not missing anything. Okay, so another cool feature of Kibana when it comes to working with the data and retrieving the data is this DevTools. And this is what developers love to use. Personally, I really like to use this feature. It allows you to run queries over your data. So let me very quickly show you where the data is actually stored. So if you scroll down to data management, then index management, you can see the actual index that is created for this imported data. And we shouldn't forget, this is the sample data that we imported from Kibana. This is not something that we have collected and sent to Elastic, but we will get to that as well. So as you can see, this particular index has almost 13,000 documents. So it's not that big, but it has a very reasonable size. So let's say we want to work with this data. We want to understand the data, then run some queries to filter out based on certain conditions, and then move forward with more advanced queries, because that's particularly what you are going to do when you want to collect some data. You want to, in the end, to be able to run queries, to filter out some of them, then to get some statistics from your data. In order to do that, it allows you, Elasticsearch gives you a syntax that you can run your queries. So first, you need to specify the name of the index, which is Kibana, and this autocomplete feature is super handy. It gives you some suggestions that you can complete, and running queries would be much, much easier. So if I run this query without any specification, it just tells Elasticsearch, okay, give me everything you have on this index. And by index, we mean something like a table in relational databases. So index is somewhere that we store our data and collect our data inside. So basically, by running this, we told the Elastic that we want to get everything from this particular index. It gives me some results. It says that we have a total number of 10,000, but it's not accurate, and I will tell you why. 10,000 documents, and this is the structure of the data that we have with these fields and their values. And this is another index. So each index is inside another JSON object. So first of all, we should always track these total hits to true. And this will tell you, okay, give me whatever you have, because without this command, it tries to first give you a brief information in order to be more fast, more quick, have more quicker response. But with setting this to true, we just tell it to give us everything. So we have in total 13,000 documents. And it will give you a number of the documents that it found. We can specify the number with the size feature, like, for example, 20 of them, 100 of them, or 1,000 of them, whatever size we would like. Let's stick with 10. And then we can add more conditional statements. Like, for example, if we go through the fields in this data set, we will have some fields like canceled or delayed. I cannot find the delayed one. Let me just search for it. Yeah, flight delay. So what if I want to just retrieve the documents that were canceled? I can retrieve it by adding a query statement, and I'm looking for a certain field, which is the canceled, right? The canceled field. And by adding the field and specifying the value of the field, we can only select the documents that have the cancel field set to false. Or actually, if we want to see the canceled ones, we should see the canceled set to true, which is almost 1,600 documents. And we can go crazy with this thing. Like, what if I want to filter out my data for all the documents that are destination set to US and cancel. So basically, and query for between two fields. First the destination country, then the canceled field. I can do it by specifying the bool statement. And with this bool statement, we must specify the the operator, which is either and or the or operator. For and, we will use must. For or, we use should. So in here, we need an and operator. We specify the must, and then we specify the actual query that we want to, sorry, let's just sort the indentation. And this is the actual query that we want to run for one of the ands, and the other and would be specifying the destination country. So in the field, we set the destination country, and for a value, we set it to US. So only 246 documents are both to the US and have been canceled. And again, you can combine as many as these queries together to come up with very, very complex queries. So moving on with the more advanced features of data query for Elasticsearch, which is a very cool feature called aggregations. So with aggregations, you are allowed to run statistics or get statistics. So let's assume we want to understand how many of these devices have been canceled, how many of them haven't been canceled. We use a term query, and for a field, we use the canceled field. If we run this and we set the size to 0, we can see that it gives us some statistics. So basically, it categorizes everything in that index and gives us the numbers. We have 11,000 falses for canceled field and 1,600 for truth. And again, we can make this more complicated. Like, for example, I want to know how many of these canceled ones or not canceled ones are distributed over time. So how many per hour? So the aggregation type, I set it to date histogram, and the field, the actual date field that we are going to use is timestamp, and the type of histogram that we are going to use is the calendar interval, and the value would be 1 hour. So by running this, we can see that all of the false values, false documents for the canceled ones are the distributed over time within 1 hour. So we have 9 different documents within the first hour, 9 other documents within the second hour, 10 other for the third, and go on. So you can run all sorts of complex queries to get a statistical data over your data. Okay, so let's move on to how we can actually get data from outside, from an external source, which is, for example, our own laptop. I'm going to use Logstash, which is one of the main modules of Elastic Stack. And I'm going to use this Logstash to import these two data sets, which is the UNSW data set. It's a known data set in network anomaly detection or intrusion detection. We are first going to import this training set, and then we are going to run our machine learning on the testing set, which is something that you normally do. But we are going to do everything inside Elastic. So first, let me show you the config file for Elastic, for Logstash. In here, we basically specify the file that we are going to import, the location, which is from the beginning, the columns that this data set has. It's not mandatory to include, to specify the columns, but it's very recommended, because if you do so, Elasticsearch would be able to map every field to its proper data type. And this is the actual definition of these fields to their proper data types. And in the end, you'll specify where to send these data, because Logstash is going to be running on our local machine, and then these data is sent to Elasticsearch, which is hosted in a cloud. So we need to specify the location. So this is my credentials. This is a 2 weeks trial, so it's okay to use it, but please don't use it. But you can just specify your own credentials here, and the data will be sent to Elastic. So if we run the Logstash, I'm going to run it with a process, but you can run it as a service, so it constantly monitors the data for you. It will, and I'm going to run the training configuration, which is mapped to the training set. And as soon as I hit run, it will just first read the data set, the CSV file, and parse everything inside that data set, and send the data to Elasticsearch. As you can see, it is parsing the data. And if we quickly switch to this index management, we can see this new index, and we can see the actual data that is coming to this index. And we can do the same with the DevTools as well. So let's change this to this new data set. We need to refresh to be able to see the new index. And we should set the track total hits to true to see everything. 55,000 documents so far are imported. As you can see, it's super fast. It's sending everything from my laptop to the cloud, but it's super fast. And again, it's scalable. You can run multiple instances of Logstash to read your files in parallel and send it in parallel. So let's wait for a couple of seconds to collect everything. And as you can see, it has a very flat structure. It has so many features which are used for anomaly detection, intrusion detection. We're almost there. And as you can see, we can run our queries on this index as well. It's super fast, although we have almost 200,000 documents, but it's super fast. And we can run complex queries. And this is one of the key characteristics of Elasticsearch. It can handle gigantic volume of data. Okay, I think we are done. Yes, so it read everything, parsed everything, and sent everything from that CSV file to my cloud instance. So I have everything. I can run different types of queries, but this is not what we imported, why we imported this data set. What we are going to do is going to run a machine learning model to create a machine learning model over this data set inside Elasticsearch. And this is a very advanced feature in Elastic. So if we switch to machine learning tab, first of all, if you're doing this for the first time on your deployment environment, it might ask you to create a machine learning instance, but it's very straightforward. It might take a couple of minutes. I did it in advance, but it's super straightforward. And in order to create a machine learning algorithm, it gives you two types of machine learning models. The first one is the anomaly detection, and the second type is data analytics. So for the anomaly detection, it supports these types of, one more thing. In order to be able to run the machine learning algorithms, you first need to create a data view for your new index. And if we search data view here, we will go to the data view page of Kibana and then create a data view and then specify this new index that we created, specify the pattern which we will use the name of the index and then the timestamp field in our index, which is the timestamp field. I'm going to minimize this one because I won't allow me to see this. Yeah. So as soon as I create this data view and then switch back to machine learning tab, it will allow me to use this data set to create the machine learning model. And for data anomaly type, it covers different types of machine learning models like single metric, multi-metric, population, categorization, and etc. For this presentation, we are going to use the second type, which is the data analytics. And for this type, it covers three main machine learning models, including outlier detection, regression, and classification. We are going to go with the classification type. We select this model type. It shows us different fields that we have in this data set. And then we need to specify the actual label that we want to predict. Actually, we want the model to predict for us, which is the field label in the data set. Then it shows us the different fields that we can select for the machine learning job. We leave it as the default fields, but we can customize the fields, unselect or select more fields. It shows us some charts to understand the data better. And then we specify the percentage of the data set that we are going to use for the train and test phase. And then we can set different hyperparameters like the lambda, gamma, alpha values, all sorts of hyperparameters that are used for machine learning jobs. And we can specify a job title, which we call it UNSW classification job. This is going to be the name of our model. And specify the field for timestamp, and it validates the data first. And then by checking the start immediately, as soon as I hit the create button, it starts the training phase. And if we go to the jobs tab, we can see the status of this training phase. It takes a couple of minutes to train our machine learning model over the data set that we imported, and then it will give us the actual model that we can use for the new data. So because that's why actually we create the machine learning models, right? We train the model over a training set, then we use that model for the unseen data. But the beauty of using machine learning module in Elasticsearch is we can do it within Elasticstack. Then we can reuse the created the model for the incoming data, new data that we have for the index. And once this is finished, we will go over that section as well. It will normally take a couple of minutes to finish the training phase, and it's closely related to the size of your data set. The larger the size of the data set, the longer it will take to train the model over your data. But as soon as it's finished, I will show you how we can reuse. I will first show you the results for the machine learning model for the training phase. Then I will show you how we can reuse this model uh, for the new data that we have, which will be the testing test. So we will do the same thing, import the data with Logstash from our laptop, send the data to a new index. But before storing the data in that index, we will run the machine learning model over the data to have the results. Let's give it a couple more seconds to finish the training. It's almost done. 7 phases out of 8 are finished, and the last phases are just for writing results. So our machine learning model is almost ready. Give it a couple more seconds. Okay, the training phase is finished. Then if we switch to the results, we can see the results. The accuracy is 100%, and it might be too good, but we will see. And the other results that we have for machine learning model. And these are the actual predictions that we had for the training phase. So if we switch to DevTools, I want to show you what we have here. So sorry, switch to index management. We have a new index, which is the name of the job that we created, UNSW classification job. This is the index that we created for the training phase. So if we run queries over this index, we will see not only the raw data that we have, but also this new section, which is for our machine learning model. So this is actually the thing that the model learned and added to the document. So it ran the machine learning, the classification model over the raw data and came up with these predictions. And by label, we mean either attack or not, or normal data. So if the label is set to 0, it means that it's normal data, but if it's set to 1, it means that it's attack. So, okay, the training phase is finished now, and we have the results. That's perfect. We can see that the model is capable of detecting attacks versus non-attacks with 100% accuracy. But this is not why we trained that model. We want to be able to run this for other data, for the unseen data, and hopefully for the stream data that we might have, we might receive in the future. So we can do that with, sorry, this won't allow me to switch tabs, to use the trained model. So if we switch to, again, machine learning, and then train models, we will be able to see this model that was trained. And we can easily deploy this as a pipeline. And in here, we will need to specify a couple basic fields, like the name of the pipeline that we are going to use, the structure of the field that is going to be added in the data, which is, we leave it as is, and some of the configurations that we might be adding to the processor, we leave the defaults, the specification for the failures, like what happens if one document cannot be run over the model. We add these fields to the data, like the index, the timestamp of that document, the message, the reason for failure, so on and so forth. And then we can, before creating the actual pipeline, we can simulate the pipeline. So this is a sample data. We can customize the values and add something to it, and then run the pipeline to see the actual results. So if we change the fields that are important in our model, it might actually affect the results. So for example, with the previous values, the label was 1. Let's change some of the important fields, and we might be able to change the results. But we are not going to spend too much time on it since we are almost out of time. But you get the idea, right? So we can simulate running the sample data over the machine learning model that we trained and see the result to make sure that the pipeline works. If we hit continue, we see a summary of the pipeline that is going to be created, and then the pipeline is created. So this is a pipeline that we can use for our new incoming data. So what I'm going to do, I'm going to create a new index, and for that new index, I'm going to paste the name of the pipeline here. I'm going to name it the testing set. That the old index was called the training set, right? Let's switch back to index management. We have this training set. So we will create this testing set with some specification like number of shards, number of replicas, and we will specify the default pipeline for this index. And as soon as we create this one, we refresh here, we can see this new index, which has 0 documents, right? But we have specified the pipeline for it. So the machine learning model is set for that index. So if I switch to my laptop and stop the Logstash and run it this time for the testing data set, it again imports everything from that CSV, which is this testing set CSV, parses everything and sends everything to Elastic. But before storing each document in Elastic, it runs that machine learning model over it and stores the result. And it's perfect because we don't need anything, any Python or any type of script that runs the data over a model and then sends the results or adds the results to our raw data. So if we take a look at this testing set, which is our new index, we can see that the new data is coming, 52,000. Since it's indexing, it will be a little bit slower, but as it stores most of the data, it will get faster and faster. And as we might guess, we will have that machine learning object, which is the results of that model being run over the data. So it's perfect for cases that we have stream data, but we have a machine learning model already trained over a training set, but we want to run that model over the data while the data is getting stored in Elastic. And the beauty of index pipelines in Elasticsearch is that you can add so many things to it. And we are not going to do that because it will take so much time. But if I can, I show you, you can see that this default pipeline that we have set is an inference pipeline, which is a machine learning, but we can add so many other things to it. So for example, if our machine learning model requires a specific field with a specific value, which is not already in the data set, or we need to transfer some field to a specific value type, we can add processors that, and then prioritize the processors that does this for us. So I think this is a very powerful tool that we can use in our data pipelines. And this embedded machine learning feature gives more and more power to our data pipelines. This is the end of my presentation. If you have any questions, please ask. I will be happy to answer.
Thank you, Amir, for this insightful and great presentation. We do certainly have a lot of questions, but we don't have time to take all those questions. But we can, certainly take one at random, and then we'll, certainly, wrap up for the day. So this question is, with Elastic Stack built-in machine learning capabilities, what are some of the common use cases where anomaly detection and predictive analytics have made a significant impact?
So in security monitoring applications, we normally have streams of data that come to our system. And then we want to predict something, whether it's an anomaly detection or whether it's a predictive analysis, whatever. The main impact of using machine learning on Elastic is the fast and reliable capability of integrating machine learning jobs into data processing.
Mhm.
So many of the companies that I mentioned in my presentation are using the same capability, especially in security monitoring. They have their own machine learning models that run over the data. It can be transactions being processed for finding fraudulent transactions or inaccurate transactions, or the security applications. You can think of a lot of use cases for using machine learning with Elastic.
Okay, thank you, Amir. With this, we come to end of this webinar. And once again, thank you for the outstanding presentation and rounding out the cybersecurity awareness month on such a high note. Your insight on the Elastic Stack capabilities have given us a lot to consider, and we thank you for that. We thank you for that once again. I also want to extend my gratitude to people who joined us on this webinar, or even if you're somebody who joined us on all the previous webinar or just on this one, your participation was highly valuable to us. We hope that these discussions have broadened your understanding on the scope of cybersecurity challenges, and inspired you to apply these insights into your own work. As the Cybersecurity Awareness Month comes to a close, let's keep the conversation going and continue to advocate for a secure and resilient future. Thank you once again. We look forward to seeing you in the future events. As of I, as of now, this is me, Sumit, and our guest Amir, signing off the webinar. Goodbye, and have a good rest of the day.
Thank you. Goodbye.
Thank you.